Welcome back to my session on looking at series circuit and parallel circuit and series parallel circuit in electrical technology. Now, here I have a series parallel circuit, and what I'm going to do with this circuit is to help you decide how you go about solving total resistance in a circuit looking like this. So you need to first look at how you're going to approach the circuit. Now this can be confusing to a lot of students, and because of that, this is the real reason why I want to go through this as a procedure. Now if you're going to approach a situation like this to find out how to solve or to find the total resistance in this type of circuit, let us move over a bit to simple series circuit and simple parallel circuit and see how we can use that in assisting you to come up on your decision where to start working out a circuit looking like this. So first let us shift over a bit. So here we have a simple series circuit here. On this simple series circuit, you notice there are two resistors in series. They are connected end to end. Now you may have a third resistor connecting end to end, but we are just working with two for this time, just to make things to be a little bit simple. Now here we have a parallel circuit, and we have two resistors connected in parallel. So we have R1 and R2, and again we can have a third resistor connected down here, but to make things a bit simple, we are going to work with the two resistors in parallel. So when you're approaching a circuit looking like this, you first need to decide where you can work out. Now let us shift a bit to look at this series circuit to see if we see anything that is similar to this connection in this circuit over here. So let us go back to here. We notice that we have resistor 1 and 2 connected end to end. So is there any circuit over here with any resistor connected end to end and it has no other connected parts to it in between these resistors? So let us look at this example and see if we see anything similar to that on this diagram. So we could not use this because this resistor have a connected resistor in between. Also we could not use this because these two, because we have a resistor connected in between. On the other hand, we have this resistor 3 and resistor 4 as our starting point because there is no resistor connecting in between these two resistors. So basically you could add resistor 3 and resistor 4 together just because there is no resistor connected in between these two resistors, so that we could have anything interfering with these resistors. So the first thing we look at is these two resistors, because they are connected in a similar way to these two simple ones without any other connection to it. So what it means is that we can add these two resistors together. Now when we add these two resistors together, they become one single resistor, and that resistor value, assuming that this circle or this area is one single resistor. So let us see what circuit it now forms with R5. So R3 and 4 now is one single resistor because we now assumably add them together, so they become one resistor along with R5. And let us move across to the parallel circuit. it may turn in a particular direction, but let us switch it in another direction. And if you notice it in this direction, the resistors looking down would look similar to the resistors in this diagram going down. So R3 and R4 being one resistor and R5, so we now have a parallel circuit here, and we can add the one big resistor to resistor 5 in parallel to now make it be another big resistor added to that. So this is the procedure that you would first have to take. Add resistor 3 and 4 in series, and then you look at this circuit again and see what circuit it forms, and based on the junction here we see that it forms a parallel circuit. So we add this big resistor with R5 to make one single resistor that we have here. So this entire section here would be one single resistor when we add these resistors together. So what circuit is formed with R2 with this one big resistor that is here? Now if we notice, we have resistor 2 coming in, and then with this one big resistor is one single resistor, so it now forms another circuit looking like this. So because of that, we now add R2 to this one big resistor in series so that we can have that part of the circuit added. Now when we add all of that together, and we now again have one big resistor with all of this here, we now look at the circuit along with R6 to see what circuit it forms. So based on the junction that is here again, we notice that this resistor that is big here along with this R6 now forms another parallel circuit. And if you look on this diagram, look at it in that direction, you can see that it looks like the parallel circuit that is formed here. So we were now assuming that all of this would be one single big resistor, and it is in parallel with R6 here. So then you add R6 to this one big resistor in parallel, and you are now left with R1 with one single big resistor going back to the source. So assumably this is positive and this is negative, so you now have R1 along with a big resistor, and then it goes back to the source. So let us see what circuit that would form. So if we notice here, we would have a circuit looking like a series circuit. So in order to complete the addition for this type of circuit, you now add R1 to this one big resistor in series to get the total resistance of this circuit. So this is how you would need to approach a circuit looking like this. And we need to remember that even though this looks like this, you can have circuit diagrams looking like different drawings. So you would need to look at them individually, the sections, and look at what looks like this as a series circuit, or what looks like this as a parallel circuit, and there is no other interfering resistor in between. So this would be an interfering resistor to decide if this can work along with these two. But as is, this, because it is here, we could not add it to R3 or we could not add it to R4 because we would need just one resistor here, but we have two. So we had to add R3 and R4 because these are the only two resistors that we could use without any other resistor connected directly in between it. So this is how you would have to approach a circuit looking like this in order to get the circuit drawn properly. are done properly added to find the total resistance of this circuit. Hopefully this video is of some help to you. If you find it interesting, if you find it helpful, you can please subscribe and have yourself a nice time.